Hi, my name is Alexei Bacon, and after a few vlogs, I decided to be a little bit more technical. Enough with stories of my life. So let's talk physics and mechanics, and how did I end up in this business, and why I like one manufacturer better than the others. The story began a long time ago, again, like in the beginning of year 2000. I got across my friend, who is a Swiss engineer and architect, and he introduced me to the company which was called Vitroxa. And this company has been founded by a Swiss engineer who came from precision watchmaking industry, and he applied the same principles in first in the world, probably unique sliding system, which was called Vitroxa. And I got lucky. I actually studied and worked with the guys from the company, fabricating the units and then installing the units. And we started the first exclusive Vitroxa partnership in ex-Soviet Union republics, and later on, we also introduced Vitroxa to markets in different countries. And I noticed one thing. Most important thing in the sliding glass systems is actually the placement of bearing wheels and the quality of materials, of course, and following some basic physical principles. Let's talk about equilibrium. What is equilibrium? It's 6-7 of those years. So you have to keep everything in balance, right? And there are three types of equilibrium, which is neutral. So basically represented by a little ball on a flat surface, and this ball can go like in either direction, right? So then we have unstable equilibrium. It's when the ball positioned right on top of spherical surface. And again, it's unstable because at any given moment, with the forces pushing that ball, it can move like either way. And finally, we get to stable equilibrium when all the forces, the combination of all the forces gives you zero. So that ball doesn't go anywhere, and this is like stable. So this ball is basically, super stable, doesn't go anywhere, stays in one place. So earlier Vitroxa systems had a bearing wheel surface which was flat, contacting the flat surface of a special plate underneath the glass panel. And that actually is neutral equilibrium, because this glass panel during sliding can actually deviate to either left or right, creating friction. So we have different kinds of friction as well. And one of them is sliding friction, and one of them is rolling friction. This is what applicable here. So the sliding friction is the friction between the brushes and the wall of the extrusion and the glass panel, so in this area. And the sliding friction, of course, is the friction between that plate and the bearing wheel. What happened there? Initially, Vitroxa has used some brass plates underneath the glass panel, and unfortunately, brass is kind of soft material, and that friction is substantial. And also because of neutral equilibrium, the friction is not even, and as I said, because of the panel can deviate from straight direction, the friction on either outside or inside surface can be different, and it actually may result in the panel stuck and some, difficulties sliding this glass panel. The first system, which was like Vitroxa 3001, had limitations as for dimensions and the total weight of the panel. So in later years, they have developed a new system, which they call TH Plus, with 2 rows of bearing wheels, and basically the same system. I don't think you can see it, but well, it implements the same plate, which is perpendicular to the bearing wheel. And again, this is classic example of neutral equilibrium. So basically nothing has changed except for the second row of bearing wheels. And again, it can deviate from like straight direction to the left, to the right, and it creates twice more friction, both rolling friction and sliding friction. So then the inventor of the system, Monsieur Eric Jaurès, who unfortunately has died like 3 years ago, came up with the idea of different placement of bearing wheels, and he called it 4x4. And actually, the idea of this placement of the wheels came from Swiss railways, right? We know the carriage of the railways, and it has every carriage has individually suspended wheels, and well, his idea was like, okay, if I do that, we can probably eliminate this issue. However, the wheels in that 4x4 were inclined for like 15 degrees probably, and in the wrong direction. So this is the plate, this is the bearing wheel, same thing, plate and the bearing wheel, and that situation actually represents unstable equilibrium. And just to demonstrate the similarity, I'll draw that imaginary line here. So unfortunately, this idea didn't work, and the glass panel, again, can go either to the left or to the right, creating unequal friction on the side, and causing the panel to stuck. We made with Vitroxa back then a unique sliding window of 8 panels. Each panel was 3 by 6 meters or 10 by 20 feet. And with the extensive weight of the panel, about 2,500 pounds or about like 1,200 kilos, that amount of friction became essential. And well, they had to develop a special system to center the glass panel, which was a disaster. Anyhow, now let's switch. Let me change the drawings, and I will switch to another system which we represent right now, and this is Keller minimal windows. I'll tell you the difference in a second. So we moved from Vitroxa to another system, which is Keller minimal windows. Keller minimal windows actually was developed back in 2007, and based on the experience with Vitroxa systems, of course. Keller initially manufactured some skylights, winter gardens, and like conventional windows and doors. And Keller was using Vitroxa sliding doors in their glass houses product. And then they had another idea and developed their own product on totally different physical basic principles. And now we go back to equilibrium types. So in Keller minimal windows, we dealing with stable equilibrium because they reversed the positioning of the bearing wheels, and their bearing wheels are actually carved, and they slide on the surface of stainless steel rod in the base of the extrusion. So therefore, at every moment, the sliding panel is self-centered and it doesn't go anywhere because of the stable equilibrium, and the friction is equal on both sides and minimal, and rolling friction as well minimum because of the square footage of the surface in contact, which is minuscule. Keller has developed their minimal window system. Then next iteration was minimal windows freeway, which actually brings, there is no step here, and it brings the surface outside and inside, and you know, that sliding rail to the same level to comply with, let's say, ADA requirements and not to create a tripping hazard. Implements the same principles, one stainless steel rod and a bearing wheel which has carved and curved shape. So because of this shape, it sits directly on stainless steel rod, and again, doesn't go anywhere. So stable equilibrium with minimum of either sliding or rolling friction. And finally, Keller has introduced later on their minimal Windows 4 Plus system. On the same principles. The only difference is just a pair of bearing wheels and a pair of sliding rails. Same exact carved bearing wheels and stable equilibrium, equal friction, and minimum rolling friction. This is basically it. That's why I like Keller minimal windows better. And another aspect is very smooth, silent sliding sensation. In the first place, with Vitroxa system, these wheels are located in the base, and there's a distance between them of depending on the weight of the panel. And every time that plate comes in contact with the bearing wheel, you hear that clicking sound. And depending on the speed you sliding the panel with, the sound could be click, 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 click. Not every client likes it, while in Keller, it's actually silent. It is actually as Swiss railroads. No clicking sound, stable equilibrium, minimal friction. That's why I like minimal windows better.